Could you imagine waking up one day on Mars? What would it be like to breathe Martian air? A tantalizing thought indeed, isn't it? But as it stands, the reality of Mars is less than hospitable. The thin, cold air, primarily composed of carbon dioxide, is far from the oxygen-rich atmosphere we enjoy here on Earth. But don't let that deter you. After all, we humans are known for our ingenuity and penchant for overcoming the insurmountable. Picture this. Your Martian morning begins as you rise from your sleep pod. As you take your first breath, it isn't the frigid Martian atmosphere that fills your lungs, but a breath of fresh, life-giving oxygen. As you step out onto the red soil, you gaze at the distant horizon, marveling at the prospect of a new world ripe for exploration and discovery. But how can this be possible? How can we transform the inhospitable Martian atmosphere into something we can breathe? The answer lies in our remarkable scientific advancements and our relentless pursuit of knowledge. Over the years, scientists and researchers have been pondering this very question, devising methods and technologies that could potentially generate oxygen on Mars. From extracting oxygen directly from the Martian atmosphere, to utilizing the planet's abundant water resources, various possibilities are currently under exploration. These endeavors aren't just about survival. They represent our collective dream, our ambition to push the boundaries of human potential and explore the uncharted frontiers of our universe. The possibility of generating oxygen on Mars brings us one step closer to transforming this red planet into our second home, a testament to human resilience and innovation. So let's embark on this exciting journey together, exploring the mysteries of Mars and the scientific marvels that could make life on the red planet possible. Are you ready to venture beyond the confines of our home planet and unravel the secrets of Martian living? Now let's delve deeper into the scientific methods that could make breathing on Mars a reality. Before we discuss generating oxygen, we need to understand Mars's atmosphere. Picture this: a thin, chilly blanket of gas enveloping a barren world. It's far from the comforting cushion of air we're used to here on Earth. Mars's atmosphere is about 100 times thinner than Earth's, and it's composed mostly of carbon dioxide, about 95% to be precise. The remaining 5% is a mix of nitrogen and argon, with trace amounts of oxygen and water. It's a stark contrast to our home planet where we bask in an atmosphere rich with 21% oxygen. Now you're probably wondering, what's the big deal about a little less oxygen? Well, less oxygen means less fuel for our bodies. You see, every cell in our body needs oxygen to convert the food we eat into energy. Without enough oxygen, we simply wouldn't have the energy to survive. But let's not forget about the temperature. Mars is a chilly place with an average temperature around -80 degrees Fahrenheit. That's colder than the coldest temperature ever recorded on Earth. Without a thick atmosphere to trap heat, Mars remains a frozen desert. And it's not just about the cold. Mars's thin atmosphere also means less protection from harmful solar radiation. On Earth, our atmosphere acts like a shield, absorbing the majority of this radiation before it can reach the surface. But on Mars, without a similar shield, humans would be exposed to potentially lethal doses of radiation. The low atmospheric pressure on Mars poses another problem. It's so low, in fact, that water can't exist in liquid form. It either freezes solid or boils away into gas. This makes it incredibly difficult to store and use water, a vital resource for generating oxygen and supporting human life. So we're dealing with a thin, cold, and radiation-exposed atmosphere that's mostly carbon dioxide. It's a far cry from the life-sustaining environment we're used to. But don't lose hope just yet. With this understanding of Mars's atmosphere, we can now explore how to generate oxygen. The Mars Oxygen In Situ Resource Utilization Experiment, better known as MOXIE, marks NASA's pioneering venture into oxygen production on Mars. This shoebox-sized instrument is a technological marvel, designed to convert the red planet's carbon dioxide-rich atmosphere into breathable oxygen. So how does MOXIE work its magic? Well, it employs a process called solid oxide electrolysis. This involves compressing and heating the Martian air until it reaches about 800 degrees Celsius. At these temperatures, the carbon dioxide molecules split, resulting in oxygen and carbon monoxide. MOXIE then isolates the oxygen and measures its purity, while the carbon monoxide is released back into the Martian atmosphere. This compact yet ingenious device can produce approximately 6 to 10 grams of oxygen per hour. That might not sound like much, but it's enough for a small pet to breathe. It also represents a significant leap towards self-sufficiency for future manned missions to Mars. The implications of MOXIE's success are far-reaching. It's not just about providing astronauts with breathable air, although that's certainly a crucial aspect. It's also about fuel. Oxygen can be used in the production of rocket propellant, which means that future Mars explorers could potentially produce their own fuel for the return journey to Earth. This would significantly reduce the amount of resources needed to be transported from Earth, making Mars missions more viable and less costly. Moreover, MOXIE's technology could potentially be scaled up. A larger, more advanced version could produce enough oxygen for a crew of astronauts to breathe and, at the same time, generate sufficient propellant for their voyage home. It's fascinating to think that this small device could play such a pivotal role in our quest to conquer the Red Planet. However, it's important to remember that MOXIE is still in its experimental stages. It's a proof of concept, a stepping stone on the path to future technologies and methods of oxygen production. MOXIE is only the beginning. There are other methods to generate oxygen too. Water, a simple molecule with 2 hydrogen atoms and 1 oxygen atom, could be our ticket to breathable air on Mars. Imagine a world where ice caps and underground reservoirs are not just sources of life-sustaining hydration, but also oxygen factories. This is the Martian reality that scientists are working towards. Mars, our neighboring red planet, is home to vast ice caps and suspected underground water reserves. The potential of these water sources in the production of oxygen is immense. The key to unlocking this potential lies in a process called electrolysis. This is a well-established technique here on Earth, used in various industries. But the idea of using it on another planet to create a breathable atmosphere, now that's truly groundbreaking. Electrolysis involves passing an electric current through water to separate it into its constituent elements, hydrogen and oxygen. The oxygen can then be collected and used to replenish the atmosphere, while the hydrogen can be used as a fuel source. It's a neat, self-sustaining process. But before we get too ahead of ourselves, let's address the Martian elephant in the room. Where will the electricity for the electrolysis come from? Well, scientists have thought of that too. Solar panels, nuclear power, or even wind turbines could be used to generate the necessary electricity. There are, of course, challenges to this approach. The Martian environment is harsh, and the equipment will need to be rugged and reliable. Furthermore, electrolysis is an energy-intensive process. However, the potential rewards are too significant to ignore. By transforming Mars's water into oxygen, we could create a self-sustaining environment for human inhabitants. Not only would this provide a lifeline for potential Martian colonies, but it also opens up the possibility of extended stays, or even permanent habitation on the Red Planet. In the grand scheme of Martian colonization, the ability to produce oxygen from water is just one piece of the puzzle, but it's a critical piece, and one that could enable us to take our first breaths on another planet. As you can see, water could play a crucial role in human survival on Mars. So, is it possible for humans to breathe on Mars? As we've seen, the answer is both complex and fascinating. The Martian atmosphere, composed primarily of carbon dioxide, is not suitable for human breathing. Yet the human spirit of exploration and innovation is never deterred by mere impossibility. Remember the MOXIE experiment we talked about? It's a revolutionary project that's part of the Mars 2020 mission. This shoebox-sized device is designed to convert the abundant carbon dioxide in the Martian atmosphere into breathable oxygen. It uses a process called solid oxide electrolysis, where electricity heats up the carbon dioxide to produce oxygen and carbon monoxide. Early results from the MOXIE experiment have been promising, showing that it's indeed possible to produce oxygen on Mars. However, it's important to note that MOXIE is still in its testing phase, and producing enough oxygen for a human colony is a challenge that still lies ahead. But the MOXIE experiment isn't the only avenue of research. We've also discussed the potential of generating oxygen from water. Mars, despite its barren appearance, has vast reserves of water ice. Through a process called electrolysis, this water can be split into hydrogen and oxygen. The oxygen could then be used for breathing, and the hydrogen could serve as a potential fuel source. While both these methods show promise, they also highlight the vast amount of work that still needs to be done. Converting carbon dioxide into oxygen or extracting it from water on a large scale are tasks that present significant technical and logistical challenges. But let's not forget that just a few decades ago, the idea of humans setting foot on the moon seemed like an impossible dream. Today, we're seriously discussing how to produce breathable air on a planet millions of miles away. While we are not packing our bags for Mars just yet, these scientific advancements bring us one step closer to the dream of living on the Red Planet.